Welcome. This is the Cisco CCNA ENSA, also known as the Enterprise Networking Security and Automation course. This course focuses on the CCNA version 7 curriculum. This is course 3 of 3. Module 9, QOS Concepts. So in this module, we're going to be talking about quality of network transmissions, traffic characteristics, queuing algorithms, different QoS models, and implementation techniques. So let's go ahead and jump right on in. So let's look at network transmission quality. So inside the Netiquette system, they do have some of the videos which they like to put up in our PowerPoints, which I'm not covering the video. I'm just going to quickly explain what QoS is. QoS is essentially a way to prioritize traffic. If the router is feeling overwhelmed and it can only process one packet and two packets show up, which packet should it forward? Which packet should it process? Without QoS, first come, first serve. However, with QoS, we can look at certain things like class of traffic. Is it a real-time traffic protocol? Is it something like voice or video? Something that has a real-time component? Or is it just regular data that can take an extra millisecond to be displayed? So the nice thing is, normally, UDP is used for our real-time traffic. TCP, with it being connection-oriented, being guaranteed delivery, the additional overhead is normally connection-oriented and is not really suitable for real-time traffic. So we can prioritize maybe off of protocol type, or we can actually look at protocol header information, and that will define certain QoS features. Alright, so in Wikipedia, we can see a pretty common IPv4 header, and we can see right here we have this TOS. Different view, same thing, IP header. The TOS was replaced by this DSCP. DSCP is essentially, again, originally defined as TOS, but this basically was a differentiated service, or a diff service. That's what QoS is. So, like I said before, it allows us to prioritize traffic. And I understand that it processing one packet is unrealistic. But when a networking device, a router or a switch, is getting swarmed with data, and it has a ton of low priority, medium priority, and high priority traffic, it's still going to send out low and medium priority. However, it's going to prioritize the higher ones first. So you may get 2 or 3 high priority packets for every 1 low quality packet. That way, the majority of the network traffic will be that high priority. And what ends up happening is the device, typically a router, will queue the incoming information. Basically, the queues are just, they hold them, and when they're able to send them, then they send them. So by querying the packets caused a delay. That's one of the negative issues with them, because newer packets then cannot be transmitted until previous packets have been processed. So as we start queuing these larger strings of packets, they become more and more of a delay, because again, we're essentially building up this bucket. We're collecting these packets, waiting to be sent, and they're not being sent for whatever reason, normally limited bandwidth. Well, the issue is all of that causes additional delay. It gets to the point where if the number of packets to be queried continues to increase, the memory of the device also then starts being filled up. Once the resources of that device are filled, they start dropping packets. So one way to fix this, again, is querying traffics, looking at the traffic characteristics, and prioritizing what type of traffic should be sent first. And that's part of what that prioritization is. So what's the big deal? I mean, how does this get used real world? Well, real world, I mean, even with 100 meg, 200 meg, 400 meg plus internet connection, keep in mind business is slightly different from home internet. So the same speeds that a home user get are not what a business would be getting. I pay for a gigabit home connection, and I have a 200 megabit business connection. My business connection is 3 times the price of my gigabit home internet. With that said, I have to prioritize certain types of traffic over that business line. I do a lot of large data transferring, but I also do a lot of voice. So I prioritize all voice traffic first. That means the majority of the data sent first on the business connection will be voice. The data can actually take a back seat. The voice has a real-time component that I need to be concerned about. And again, some of the reasons are going to be things like aggregation, speed mismatching, LAN to WAN. Again, you may have a gigabit LAN connection, but then it has to filter out through whatever internet connection you have. Again, 100 megabit, 200 megabit, and so forth. These are all main reasons that transmission quality may go down. So what is this jitter? When we talk about voice, jitter is going to be the more like robotic talk that you may hear while dealing with voice. Jitter is noise on the wire that actually is dealing with interference or delay of that voice packet being sent. Other things could be like network congestion. The sad fact is, with streaming technologies now, especially in the business, more and more people are consuming network resources by streaming music and YouTube and whatnot, even though it's not business related. The business has a network, and that network only has a limited amount of speed. So sometimes poor design plays a huge part of not enough bandwidth to have the organization run correctly. Alright, so let's dive a little bit deeper into that delay. So delay or latency basically refers to the time it takes for a packet to travel from the source to the destination. Normally, there's a fixed delay as the amount of time that specific processing takes, such as how long it takes to place a bit on the transmission media. That's all fixed, like we know that. However, there is a variable delay. Basically, this is an unspecified amount of time that is affected by factors such as traffic processing, traffic over the wire, and media transmission issues that are outside the norm. And again, the textbook definition of jitter is going to be that the variation of delay of the received packets. Not just the sent packets, but received packets. So we can see that we have a few other forms of delay, like a code delay, a packetization delay, a queuing delay, a serialization delay, a propagation delay, and a de-jitter delay. You guys can read the descriptions of each of those. We always assume that a network has the appropriate amount of bandwidth, but realistically, if it is not planned for, then equipment normally does not. I've actually seen more recently, in 2020, 2021, and so forth, that they still sell 10100 megabits per second based equipment. And I still see businesses implementing 10100 megabits per second equipment. I actually just seen a business buy 3 new switches where the 10100 was cheaper than the gigabit. But no one thought about, long-term investment of that equipment. The gigabit was, $50 more expensive per piece of equipment, but the likelihood of that equipment lasting over the next 5 years, well, the 10100 probably won't, where the gigabit probably would. So when we're talking delay, we have to look at how the network is set up, the type of traffic on the network, and then we need to look at the traffic itself. Are we actually consuming the majority of the bandwidth on the network? So If we are assuming there is some type of delay and queuing happening, there could be packet loss because of those features. If it has to queue and the memory is filled, eventually packet loss will occur. So without some form of QoS mechanism, time-sensitive packets, again, real-time traffic or voice, video, could be dropped at the same frequency as regular traffic. Again, real-time traffic has a real-time component, which means they need to be given priority. But if they are given the same priority of like a website, for example, then they run the risk of being treated like a regular data packet, not one that has a certain level of priority. Again, the importance of that is priority is essentially saying, oh, this has a real-time component, it needs to go first. So if the jitter is so large that it can cause packets to be received out of a range of the play or buffer order, out of range packets, essentially they are discarded. So losses for a small amount, like maybe a single packet, digital signal processor, DSP, will basically interpret what's going on and play back that type of audio. Realistically, this happens pretty common and you don't normally notice the difference. However, the more jitter occurs, the harder this DSP process it is to interpret what should be going next. So you start ending up with portions of a sound clip or voice call or video that sinking mouth is moving without audio, or there is like a half a second delay. One of the more funny commercials that I've seen lately is a guy taking an elevator and he's calling out for help, but everything is offset by 5 seconds. So that's what it's mean by jitter, that offset in audio quality, that offset in audio response, so that someone actually cannot understand or interpret what is going on. And that is it for this module. If you got any questions or concerns, please reach out. Thank you.